Good morning, everyone. Welcome to Physics Unveiled. This particular session will be keeping it very short because in this particular session, we'll be uploading some 20 best numericals of motion in 1 dimensions. As we have completed our motion in 1 dimension in our last session, where we have discussed about the concept of relative velocity, relative motion specifically. So I thought, why not collect the best numerical, which will touch all the concepts that we have read so far, and so that the understanding part of us in this particular topic grow more solid. Okay, so there are 20 numericals that I have chosen, and while choosing this problem, I take care of only one thing, that see, there will be no limits of numericals. Okay, but you can definitely fix it up to a range where it can cover almost everything that we need to understand and need to understand to solve the future problems on numericals. Okay, so you can see the 20 numericals are there, and all these 20 numericals I want you to try at your end first. I'll be posting the solutions of these numericals by Saturday after seeing the submissions from our subscribers and the students from the Zoom classes. So as they perform, I'll definitely point out the kind of errors that they have made while solving this. And if you find any problem in understanding a particular numerical, you can reach to us by commenting on our video, or at the same time you can post your comments to us, or you can write to us in the email ID that we have given in the description box. So with this, I'll be just narrating down the problem one by one and very quick. The first problem is about a bird which is flying at a velocity. Velocity value is given before you, and there is a wind which is blowing in the x direction with a velocity of u. And if a bird starts when it starts its motion from A to B, and takes some time to reach point B. And if the line AB makes an angle 37 degrees with x-axis, find the value of U. It's a very simple problem. I'll not disclose the kind of techniques that is involved here. Second problem is again a very simple problem. We are gradually increasing our degree of difficulties. Find the change in the velocity of tip of the minute hand radius 10 centimeter of a clock in 45 minutes. Now you know that the change in velocity in 45 minutes, it may be asked in different format, like find the acceleration, but I'm not asking in that way. I'm just asking the change in velocity. Okay, third problem is based on again the relative velocity that we have recently touched, that rain is falling with a speed of 20 meter per second relative to the air, and a person is running with a velocity of 5 meter per second in the direction of east, and wind is also blowing towards east at the speed of 15 meter per second. Find the angle, the vertical, at which man should hold his umbrella so that he may not get wet. This is a practical life problem we always face, that whenever it's raining outside, we have to adjust the angle of our umbrella according to the direction of rain. So now the fourth problem is the velocity is a function of time. Then we have to just find out the acceleration versus time graph and acceleration versus time equations and the position displacement versus time equations. Okay, so how we are going to find it out, that you have to understand, that you have to figure out. And if you're not able to figure it out, I'll recommend you to just browse to our kinematics playlist 1D, and where we have discussed all the necessary concepts. And at the same time, you might need the concept of differentiation and integration. So for that, you can browse to our foundation classes playlist as well, where you can specifically choose those two videos to understand the concept, and then you can apply and come back to this problem. Fifth problem is assuming a car is able to stop with a retardation of 8 meter per second square, and a driver can react to an emergency 0.5 second, calculate the overall stopping distance for the car for a speed of 60 km per hour. So it's again a practical life questions, where we see that all of a sudden, if you see something before in front of our car, then we take some time to react to the situation, and that is called the reaction time. So in that reaction time, how much the distance our vehicle will travel, that the problem is based on that. The sixth number problem is two buses A and B are at position 50 meter and 100 meter, and they started at t equal to 0. They started moving in the same direction with a uniform velocity of 10 meter per second and 5 meter per second. You have to just find out the time at which they will be overtaking each other. Seventh problem is very simple. The motion of gravity is again a constant acceleration motion. The motion is the ball is thrown upwards with a speed of 20 meters per second from the top of a multi-story building. The height from which the ball is thrown is 25 meters from the ground. How high the ball will rise first, how high it will go, and how long it will take before it hits the ground. So again, a very simple problem, and I have given you certain concepts of equation of motions. You figure it out that how you are going to apply those concepts here. The eighth number problem is again the graph-based problem, and I want you to be very much thorough while solving the graph-based problem, because in all the objective examinations of your future IITs or NETs and NEET will be based on the graphical based problems. So I request you to go through this problem in detail and touch the old concept of ours through the video of foundation classes, where you have discussed about the various kind of graphs. So please solve that using those concepts. Ninth number problem is a open lift is moving with a velocity 10 meters per second, and it has an upward acceleration of 2 meters per second square, velocity of 20 meters per second relative to the ground. You have to find out the time when the ball meets the lift, and displacement of lift and ball at that instant, and distance traveled by ball to that instant, take g equal to 10 meters per second square. सो जिस टाइम में ये बॉल अगेन लिफ्ट से आप फेंकते हैं, जब वापस से लिफ्ट में आएगा उसी टाइम में डिस्प्लेसमेंट क्या कवर करेगा बॉल, वही आपको निकालना है. 10th number problem is the famous river and boat problem that we have touched in our last session of relative motion only, where you have to find out. But in this particular problem, in one problem only, I have tried to find out all the possible scenarios of a river and boat problem, like the distance, the minimum time, the minimum drift, everything. I have just tried to covered in the simple. So if you have not seen our video of relative motion, I recommend you to go over there and try to see that how we have discussed those concepts. The 11th number problem is the amalgamation of mathematical tools of physics, where we have discussed about the sine and cosine rule. You can use that also. At the same time, you can solve this problem using the relative velocity concept. The aircraft flies at a 400 km per hour in still air, and a wind of 200 kilometers, is 200 kilometers, not 2, is blowing from south, and the pilot wishes to travel from A to B in northeast of A. See, I have drawn everything. Find the direction he must steer and time of his journey. It's a very simple problem if AV is given as 1000 kilometers. So AV is given. 12th number problem, a man standing on a road to hold his umbrella at 30 degrees vertical to keep the rain away. And he throws the umbrella and starts running. Then he finds that raindrops are hitting his head vertically. Find the speed of raindrops with respect to road and moving man. Again, it's a relative velocity problem, rain versus man. So please go through that video again and try to understand the concept and come back to this if you are feeling any problem in order to solve it. The problem number 13 is a very simple problem. It is again using multiple concepts. You can solve it by the relative velocity, you can solve it by a sine cosine rule. So I'll not disclose the entire solution part right here. We'll be discussing on Saturday, as I've told. So you have to find out the time at which these two particles will collide, and the distance of particle from A where the collision occurs. At what distance the collision occurs. Okay, so that you have to find it out. And the fourth number, the passenger is standing at a distance D from the bus, and bus begins to move at a constant acceleration A. To catch the bus, passenger runs at a constant speed U towards the bus. What is the minimum speed of passenger so that he may catch the bus? Again, let's say like it can be this problem can be remodeled in different format, like thief and police problem. Sometime between two particle problem, one I have given just before you, but the concept is more or less same. I understand, and I hope that you'll be able to solve it because we have already discussed this problem while discussing the motion in 1 dimensions, where we have discussed about the velocity and speed. Now in the fourth problem, if a body travels half of its total path in the last second of its free fall from the rest, find the time and height of the ball, and explain the physically unexpected solutions if you find anything while solving this problem. You'll be getting a quadratic equations, so you have to find out what kind of time that you should take to solve this to physically fit into the condition. Sixth thing, there is a displacement time graph is given to you. Sorry, there is a velocity time graph is given to you, and you have to draw the displacement time and acceleration time graph. This is a simple problem, but I think this kind of problem has touched in the recently IIT-JEE advanced paper as well. 17, a rocket is fired. Again, it's a very important. There is an involvement of two kind of acceleration. One is the acceleration of the vehicle, and second, the acceleration due to gravity. So you have to find out the time by which the particles again come back to its journey to ground. But at the same time, I have given you an extra, load kind of thing. That's the velocity time and displacement time graph for the complete journey. Now, at a distance of 500 meter, particle is thrown off 75 meter per second, and particle P is released from rest. Again, I am asking you to draw acceleration time, velocity time, and speed time graph, displacement time graph of each particle. See, I'm emphasizing so much on graphs. Why? Because all these papers of engineering which will be appearing in your next 1 or 2 years, you'll be facing this kind of problem, where the multiple graphical problems will be before you, and you have to find out and deduce your answer based on the graphs. 19 number problem is again a repetitions of 13, but here we have to just focusing on only simple thing, that minimum distance between them during their flight. And last is somehow different because a large number of particles are moving each with a speed v, having direction of motion randomly distributed. And what you need to find out, you have to find out the average velocity between two particles, average over all the pairs. Okay, so since I have told you the randomly distributed, so I'm just giving you a hint, because in a random motion a particle can move over the 360-degree pattern. Okay, so you have to keep this thing in your mind and solve this problem. And I wish you all the best. And looking forward to see your solutions with the kind. And I just want your solution in detail. I don't want any cryptic short notes, because I just want to see whether you have got our concept clear or not. Because in examination you may skip some step, but I request you or urge you, do not skip any step. Just let me see whether you are applying those concepts clearly or not, or whether you're just copying or your concept is not clear, or you're just copying pasting the things from the internet. So don't do that. Please solve it at length. Try to understand the concept involved, and I'll make sure that you will not need to solve any other problem apart from this 20 in future, as far as the motion in 1 dimension is concerned. Your concept will be rock solid, and you will be able to most of the difficult problems, even if you have not seen it ever. So with this, I'm ending the session and looking forward to your solution one more time, and requesting you again, if you have not subscribed our channel, I'll request you kindly subscribe it and press the bell icon so that you'll get the notification as well, because we are moving fast in the course of class 11. And in our next video, apart from the solutions, we'll be touching now the projectile motion of motion in 2 dimensions. So don't miss this chance, and don't miss this quality, quality things, quality materials at free of cost. So subscribe our channel, and wish you all the best.